Welcome. This is the New Elements in the Logical Data Model and Their Implications webinar, a resource for SDSFIE training. This training resource is designed for all users. The sole recommended prerequisite for this webinar is to watch the Understanding the Vector Standard video. The 3 background training resources listed here are optional, but they may add to your overall understanding of SDSFIE. All of these videos are accessible from the support section of the SDSFIE portal at the URL shown. The overall goal for this training resource is to introduce the logical data model elements new to SDSFIE-V version 5 and the rules guiding their use. The specific objectives are that the audience gains an understanding of the following: what modular models and modules, aka submodels, are, what mission datasets are and how they are useful, what functional datasets are and how they differ from 4.0 folders, what attribute groups are and how they are useful, that in 5.0 there is a rule change that elevates attribute uniqueness to the model level, what the other rules are for element uniqueness and model modularity, and finally, what the implications of these changes are to model development for both Gold and Component Adaptations. SDSFIE-V is a content standard for vector geospatial data that provides a shared, standardized schema for the types of geospatial entities and their characteristics, or attributes, which are used in Installation Geospatial Information and Services, or IGINS, and Civil Works missions throughout the DoD. Starting with version 4.0 and for each major model release, the SDSFIE vector standard includes: first, a specification document that is submitted to the DoD IT Standards Registry, or DISR, and provides an overview version of the Gold Logical Data Model, or LDM, as well as a high-level description of how physical implementation and change management are governed and executed. Second, the Gold model itself and component adaptations of Gold. And third, the SDSFIE-V implementation guidance, or SFIG, which contains rules for preparing, submitting, and implementing both Gold and adaptations. The 4.0 SFIG was published in 2015, with the 4.0 Gold LDM published in 2017. As with earlier versions of the model, the 4.0 SFIG and thus 4.0 Gold are very closely aligned to the elements present in an Esri geodatabase. As a review, let's consider those relationships between the SDSFIE-V LDM and the Esri Physical Data Model, or PDM. As mentioned, each SDSFIE-V logical data model element is defined in the SFIG. These elements, presented in the table's right-hand column, have a direct correspondence to the first-class element objects in the Esri geodatabase model. The definitions of the SDSFIE-V LDM elements and the correspondence to the objects in the Esri physical model are as follows. A model is simply a specific collection of SDSFIE-V elements. In Esri ArcGIS, models are implemented as geodatabases. In Vector 4.0, a folder is a grouping of feature types. In ArcGIS, this corresponds to a feature dataset. In SDSFIE-V, there are 2 types of entities. First, feature type represents a set of thematically equivalent features which can be expressed as records, or rows, in a feature attribute table that are linked to a geometric feature that is a point, line, or polygon. Second, object tables define a non-spatial data table that can be linked to one or more feature type records. In an Esri geodatabase, these elements are called feature classes and object classes. An attribute of a feature type is a characteristic of the features and can be expressed as a column in a feature attribute table. In Esri, an attribute is called a field. An enumeration constrains an attribute to a permissible set or numerical range of values. In an Esri geodatabase, the synonymous term is domain. An enumerant is a value within an enumeration. The enumerants for an enumeration comprise the permissible set of values for that enumeration. In Esri, these are called domain values. An association is used to establish a relationship between two entities using a foreign key in one attribute table that points at the primary key of another entity. In an Esri geodatabase, this is called a relationship class. The biggest differences between the 4.0 and 5.0 SFIGs, and thus the existing 4.0 Gold model and the 2B 5.0 Gold model, and the implications for components, are the focus of the remainder of this presentation. There are 5 major differences, 3 of which are completely new model elements. Submodels were added to support model modularity. Mission datasets were added to provide an easy method for a group of entities to be generated and shared for a specific purpose. Attribute groups were added to facilitate the creation and assignment of a set of logically related attributes to entities. 5.0 functional datasets elevate the 4.0 folder capability for generation of geodatabase feature datasets to a full LDM element with properties. And attributes, which were unique at the level of the entity under the 4.0 SFIG, must be unique at the model level, and thus require homogenization prior to entity assignment. The most fundamental SDSFIE-V element, the model, can, from a component perspective, be defined as a set of elements that define all of the content required to represent an adaptation. So, as we now know, the key differences between SDSFIE-V 4.0 and 5.0 is the variety of element concepts that can be housed within a model. In 5.0, we have a significant expansion of element types, as well as the change from entity level to model level attribute uniqueness. Each of these types requires examination and an understanding of how these new pieces fit with the existing elements and each other. Starting at the top, 5.0 introduces the capacity for model modularity. The 5.0 SFIG provides the following rules for modularity. Modular models can have submodels called modules. The example at the right is a model named HQ that contains 3 submodels: component elements, gold utilities, and gold NG911. Note that in addition to the 3 submodels, the HQ model itself may contain elements such as entities, associations, functional datasets, and mission datasets. Modules cannot be modular. That is, submodels cannot contain submodels. Modules cannot duplicate the name of mission datasets, entities, or associations from within the modular model and any or all other contained modules. They must be deconflicted prior to creating a modular model. And all elements contained within a submodel must be used in the modular model. A submodel and all of its elements cannot be changed in any way, including being profiled. Either you include all of an existing submodel in the model you create, or you don't use that submodel at all. A functional dataset is a named list of entities with a conceptual definition useful in grouping entities typically for stewardship or proponent assignment purposes. Functional datasets are linked to a model or submodel therein. Functional datasets become feature datasets in ArcGIS at PDM generation time. Unlike folders in the 4.0 Gold model, 5.0 functional datasets are now part of the logical data model as full-fledged elements with properties and can be visualized with portal tools. The same functional datasets, those with identical model name and definitions, can be reused within the modules of a modular model, that is, within the model and its submodels. Each of those functional datasets must have a different set of entities, as entities are still unique at the model level. Then, when the model is generated into a geodatabase, a union of the entities that are contained within each of the identical functional datasets would be placed into the same single feature dataset. The next new element type is the mission dataset, which is a named and defined list of entities useful in grouping entities for generation and sharing purposes within a specific mission space. As stated previously, mission datasets cannot be duplicated within a model. They must be unique with respect to model name and definition within that context. Also, mission datasets exist only at the model level. A submodel cannot contain a mission dataset. Mission datasets can be reused for another model if the contained entities all exist in the target model. Finally, it should be noted that any particular entity may belong to 0 or more mission datasets, which would be necessary for cross-functional and other widely used feature types. In this example, there is an SDSFIE-V model consisting solely of 2 submodels. Each submodel contains functional datasets, and those contain feature types. A mission dataset named Constrained Land is created for this SDSFIE-V model by referencing one entity from each of the functional datasets in the manner depicted. In the end, the new mission dataset contains 5 polygon feature types across the environmental and military operation spectrums. Next up are attribute groups, a named set of attributes grouped for use in assignment of attributes to entities or for establishing contingent values. With respect to assigning groups of attributes to entities, there are several examples that will be employed at the gold level and should be leveraged by components for entity extensions. These include 2 groups for the required foundational attributes, the IDPK primary key and the SDSID global identifier that are assigned to every entity, spatial or non-spatial, the feature name, feature description, and media ID attributes that are assigned to every feature type, and a third group for the optional foundational attributes, installation ID and metadata ID. Another gold attribute group will include the set of 4 standard real property attributes: RP interest, RP NID for networks, RP-SUID for sites, and the RP-UID, the unique identifier for real property features. Components may wish to leverage the attribute group capability for their adaptations. The example here is for the GeoFidelis HQ model, where a condition ratings attribute group has been established with the 3 cond rating attributes for the assess date, method, and value. The other use of attribute groups is to specify contingent values among the group members. Contingent values are a data design feature that allow the user to make the values in one attribute dependent on values selected in another attribute. For example, consider the dependencies between support pole material type and pole height. If the pole material equals aluminum, then the values that the pole height attribute can take on from the object height enumeration are either 10, 20, or 30. For fiberglass poles, the values would also be set at 10 to 30, and for steel poles, from 10 to 60. By creating an attribute group and including these 2 attributes, the specification of contingent values such as these is possible. For attributes, and as mentioned, there is a significant change between the SFIE-V 4.0 and 5.0. SFIE-V 4.0 held that attributes must be unique at the entity level with respect to model name, alias name, and definition. However, nothing in SFIE-V 4.0 prevented attributes with the same model names but slightly different definitions or aliases to exist within different entities, or with an identical definition but different model names in different entities. In SFIE-V 5.0, greater homogenization of attributes is mandated. Attributes must be unique at the model level with respect to model name, alias name, and definition. These are the significant new 5.0 rules for attributes. Attributes exist within a model, which, if modular, of course means the model and all of its modules. Attributes are assigned to entities in instances known as entity attributes. At the model level, attributes have these inflexible properties: model name, alias name, definition, and data type. The first 3 of these, the model name, alias name, and definition, may not be duplicated for any other attribute at the model level. An entity attribute's flexible properties include description, note, length or precision, scale, default value, constraining enumeration, is required, is nullable, and justification. Now, with an understanding of attributes and attribute groups in hand, let's consider rules about element uniqueness and duplication. In SDSFIE-V, an element's name and concept define uniqueness. Duplicate instances of an element are identical for all of the element's properties, not just model name, alias, and definition. Modular models and contained modules may not duplicate entities among it and its modules. Modular models may duplicate attributes among it and its modules, but if duplicated, they must have identical inflexible properties. Modular models may duplicate attribute groups among it and its modules, but if duplicated, they must contain identical attributes and properties. Modular models may duplicate enumerations among it and its modules, but if duplicated, they must contain identical enumerants and properties. So, attributes, attribute groups, and enumerations of modules must be aligned among the model and all of its modules before being added. As we know, adaptations are made up of extensions, changes, and profiles of a parent model. When considering modular models and adaptations of those models, there are two final points to make before moving on and discussing attributes. First, an adaptation of a modular model includes adapting both the modular model and its contained modules. Second, the Gold model and component adaptations, if modular, may have entities and associated model elements both inside the modular model and in the modules. So, the modular model may contain entities and its modules contain entities. And, as just stated, duplicate entities are not allowed. So, no entity can exist in more than one location within a modular model. Let's next consider some of the implications for the Gold model. First, if the current Gold model was validated against the rules of the 5.0 SFIE-V, it would be found to be out of compliance, mainly in the area of attribute standardization. Thus, in terms of level of effort, attribute homogenization is likely the largest task for 5.0 Gold development due to rule changes. Another significant task will be to create the 5.0 model in an adaptation submission workbook, or ASW, from scratch, that is, without a parent adaptation, as was done in the 4.0 modeling. The model lineage can, however, be preserved by specifying the lifecycle ID for each existing 4.0 model element included in the new 5.0 model. As asserted previously, a large amount of attribute assignment will be able to be avoided by using attribute groups. In fact, in the current 4.0 Gold model, over 58% of all attributes are foundational or within the standard real property groups as proposed. Finally, the current detailed models for utilities need to be completed, as well as updates to the NG911 models. Given the rule that submodels must be used in whole or not at all, the approach to offering the collection of entities in these models at the Gold level will need to be carefully considered. Finally, let's consider some of the implications for component adaptations of the 5.0 Gold model. First, while the additional elements offer greater flexibility in model organization, and the new rules add to the rigor of standardization, they also add to the complexity of the model. Certainly, there will be a learning curve as components build their first adaptation of a new major SDSFIE-V release, and that effort will need to be well supported by our team. We expect that attribute extensions will continue to constitute a considerable portion of the adaptation development process. Now, with the 5.0 rules, the first question prior to adding an attribute to an entity will be, is that attribute different from any existing attribute in the parent Gold model? Again, with respect to name and concept. If the attribute already exists there, then the entity attribute assignment of that existing model-level attribute can be made. As we have learned, only the flexible properties will need to be specified. If the attribute model name, alias, and definition are unique with respect to the existing attributes of 5.0 Gold, then the registry of other component models needs to be checked for a matching element by name or concept. thus continuing our 4.0 SFIE-based practice to strive for harmonization across component models for elements not yet in Gold. So, if the required attribute is found to be different from Gold attributes and non-Gold attributes, then it is first added as a model-level attribute and then assigned as an entity-level attribute. Attribute standardization will take some time to implement in the first 5.0 Gold model and then in component adaptations. However, the long-term payoff will be a more streamlined standard, a better understood standard, and eventually a more easily implemented standard. This concludes our presentation of the differences between the 4.0 and 5.0 SDSFIE-V logical data models and their effect on Gold and component adaptations. This concludes the new logical data model elements and their implications training. If you want to learn more about SDSFIE, its governance and use, or more detailed SDSFIE topics, visit our training resources page at the URL listed here. Thank you for your interest in SDSFIE.